Okay, so the average value of this square root function, okay, square root x minus 3, so I've drawn it over here. If I kind of, and from this interval from 3 to 12, right about here, just zoom in a bit so I can see that a little bit better. 12 looks like it's right about here. Okay, so that average value, when I look at that, you know, this from here, this average value, you know, we're probably looking at somewhere around 2 would be my guess. Okay, so just kind of estimating it, it's going to look like that. So I'm going to do this using our formula. So our average value is going to be the interval width, so 12 minus 3, or interval width of 9, and from 3 to 12, the square root of x minus 3, so the area underneath that graph. Okay, so I'm going to find the area underneath that graph. Okay, so this area here, okay, I'm going to take that area, okay, and I'm going to divide that area by the interval width of 9. Okay, and that should be giving me, okay, so I'm just going to imagine that that red box is going to be the same area as the yellow area, and I'm going to say that the height of that box is my average value, okay, or the average height. So working that out, it's going to be 1 over 9, and the area, if I integrate this, I'm going to end up with x to the power, x minus 3 to the power 3 over 2 divided by 3 over 2. So it's going to look like that. Okay, and then I'm going to integrate that from 3 to 12. Okay, I'm going to take that 3 over 2 out to make it a little bit simpler. So you get 2 over 27. And then I'm going to plug my 12 in. So it's going to be 9 square root cubed, which gives me 27. I'm going to plug the 3 into here. I get 0. Okay, so I'm going to get an area of 27 times 2 over 27. So my average height is 2. Okay, and if you look at the diagram, if you just look, yeah, that looks pretty good. Okay, so my estimate was pretty good. Okay, y equals 2. Yeah, the area above here and the white area here is about the same. So that means that would give me about the average height of that green line through that interval. Okay. So let's take a look at the next one here, from cosine x from 0 to pi. Well, this is kind of a trick question, because, not necessarily a trick question, but if I look at 0 to pi, well, do I really need to integrate this? Because I should, just looking at the symmetry of this graph, I know that area above matches the area below, so my average value should be 0. Again, just for practice, we're going to actually do it, and we see that we should get 0. So it's going to be the interval width of pi, integrate from 0 to pi, cos x. Okay, so it's going to be 1 over pi. This antiderivative is sine x from 0 to pi. When I plug in the area from sine x of 0 to pi, well, sine of pi is 0, sine of 0 is 0, so I get a net area of 0. Okay, so the average value then, if the net area is 0, the average height of this graph must also be 0. So that divided by 1 over pi is not going to affect the numerical value. Okay, so then moving on to x squared. Okay, we end up with that from 0 to 5. We want to find the average height of that. So I'm going to look at the average height, kind of somewhere, maybe a little bit lower than that. Maybe like that. Ooh, probably even lower than that. Somewhere around there. Okay, that looks like to be the average height. And again, what I'm really looking for is how do I make this rectangle the same area as a black area there? That should give me my average height right along there. Okay, so there's my average value. Okay, so If I'm going to do that, again, I'm going to take my average value is going to be equal to the interval width and then the area in that interval. Okay, so the interval width is 5. The area is going to be x cubed over 3 from 0 to 5. There's my interval width, or sorry, my area. So my area works out to be 125 over 3 minus 0. Okay, so that's the total area is going to be about 40 point something. And 41.6 repeating it looks like. And then I'm going to divide that area by 5 to get the height. So I'm going to end up with 25 over 3, which is approximately 8 1/3. Okay, and that would be the average height, right? About 8.3 repeating. Okay, would be the average height on that graph. I didn't draw this quite accurate because that's going to go up pretty high and it's going to get kind of thin in here, so that's going to affect the average value.